All right, number 12. They told you these things are similar. You've got a volume of 216 and you've got a volume of 343.
Oh, so then you just cube root it?
All right, so the first thing we have to do, first of all, you have to know this is volume. You are going to write this in a ratio form, like 216 over 343. Unless they tell you how to write it, it doesn't matter who goes on top. The next thing you must do is you must reduce. Okay, maybe you don't use the word reduce. Maybe you were brought up in an era where they say simplify. I'm dating myself. Because technically the fraction is not reduced. Okay, no, when I grew up, we reduced fractions. But that, and as I started teaching and things changed, they said reduce is not a very good word. Simplify is a better word. Do you? Well, because I grew up in an era where we talked about reducing fractions. You know, that was like a long time ago. And more recent, it's simplify. So now I'm showing my age because.
Oh my gosh.
But anyway,
I don't think it's that complicated.
reduce gives you the impression that the new number is smaller in value, which it really isn't. It's equal in value. That's why simplify is a better word. But anyway, you must simplify first. All right? Then once you simplify, you always have to go to scale factor. Now, maybe you're already there, which is great, but you need to go to scale factor if you're not. Am I in scale factor? I am not. How do we know we are not in scale factor? Because, no, what is, it's volume. What did we do to scale factor to get volume? We cubed it. So how do we undo it? So with calculators, tell me what the cube root of 216 is. 6. What's the cube root of 343? 7. All right. So now what is this called? This is scale factor. All right, I don't even know what the question asked, so maybe I better read the question. Number 12 said to find the scale factor. Oh, smaller to larger. They did tell us how to set it up. Did I set it up well? Did I get the scale factor? That's all you had to do. Next. Trevor. Oh. Number 27. The volume of a spherical balloon with radius 3.1 is about 125 centimeters cubed. Estimate the volume of a similar balloon with radius 6.2. So on 27, what is your scale factor? Okay, it says one balloon has a radius of 3.1 and another balloon has a radius of 6.2. So it's 3.1 over 6.2. Now, does this reduce? This reduces to 1/2. So that is my scale factor. Now they're talking about volume. We have to go to volume. So in order to do volume, I need the volume ratio. What do I do to scale factor to get the volume ratio? I have to take my 1/2 and I have to cube it. What's 1 times 1 times 1? 2 times 2 times 2. So that is my volume ratio. Now that I'm in my volume ratio, I'm going to set it equal to 3.1 radius has a volume of 125. Do I put 125 on top or on the bottom? Okay, 125 is associated with the 3.1 radius. Was the 3.1 radius on the bottom? Was it on the bottom? No. So therefore 125 goes on the, and what are we looking for? The other sphere. So this, oh, definitely. I thought these would be the easy ones. So let's do arithmetic. Ready? 8 times, okay, what is 8 times 5, Kayla E? 40, carry your 4. What's 2 times 8, Karen? Plus 4? Okay, carry your 2. What's 8 times 1, Travis? Plus 2? All right, so this is going to be 1,000 is going to be the volume of that new one. All right, Becky, what was your question? 16. Where's 16? All right. So it says the two figures, whatever they may be, are similar. And they have told us that surface, this is 16, surface area of one is 192, and the surface area of the other is 1728. All right. Operative word here is what? Area. So if I write this as a ratio, what did I do to scale factor to get to here? Okay, so what will I eventually have to do? But we're not square rooting right now because what do we have to do first? Simplify. What divides? They're both even. So what is 192 divided by 2? 96. What's 1728 divided by 2? 64? Okay. Let's see if we can divide 96 by 4. 24. Oh, I didn't know that. What is it? 24. 24. What's 864 divided by 4? 216. All right. 8, 6, 12. Okay. We'll see. I know the top is 2. Is 216 divided by 12? 18. Can we go further? 1, 9. So what I want to demonstrate here is if you didn't know that 1728 was divisible by 192, can you do it by 2s until you get there? All right. So this is the surface area ratio. Okay? Keyword being what? Area. How do I take that down to scale factor? It has that. If this is an area ratio, it has been squared. So what do I have to do to this? Square root it. What's the square root of 1? What's the square root of 9? Now that is your scale factor. What did they ask us? They said find the volume. But if I want to go to volume, I need my volume what? Ratio. How do I go from my scale factor? We can't go from area to volume. We have to go from area to scale factor. Scale factor is you always go to scale factor and then move from there. So what do I do to my scale factor to get volume? Oh yeah, if you are supposed to be testing, you need to leave. Are we on sophomores today? Okay. So leave your homework. Okay. So what do we do to 1/3? Cube it. What's 1 times 1 times 1? 3 times 3 times 3?
27.
Okay, so that is my ratio. Now, they said the volume of the larger. We're going to leave it on Jeff's desk if you have your homework done. The larger is 4860. That's the volume, 4860. That's the volume of the larger. So where does that go? On the bottom. Why does it go on the bottom? Because the larger surface area was on the bottom, and we're looking for the small. So we're going to say 27x is equal to 4860. What's 4860 divided by 27? 480? 180? So this is volume, so this is going to be 180 meters cubed. Brittany, you had a question. 18. Volumes of two similar figures are given. The surface area, the smaller, is given. Find the surface area of the larger. Okay, the complexity of this problem is a little bit more because we're in volume and surface area. First of all, you've been given 27 as a volume, and you've been given a volume of 125. So we are not going to mix volume with surface area. We're going to do volume over volume. Now, is that scale factor? No, that is the volume ratio. Does that reduce? It does? No. So how do I go from volume ratio to scale factor? Cube root, because to go from scale factor to volume, what did you do? So what's the cube root of 27? 3, and you got a calculator to do that. What's the cube root of 125? Okay, now that's scale factor. We've been given a surface area of 63, surface area 63, and that is the surface area of the small. It's really important that you know, otherwise you don't know where to put it. We want to find surface area of the large. So, what ratio should I be in? Area. What do I do to scale factor to go to area? Square it. What's 3 squared? What's 5 squared? 25. Okay, am I going to put 63 on top or on the bottom? Okay, if you did not bother to read that it was the smaller one, would you really know? No. So 63 goes on top and x goes on the bottom. Now what do we do? 25 times 63 equals what? 9x. Then what are we going to do? Well, or divide by 9. Does 9 divide 63? How many times? We do need work. What are 7 quarters? Well, how much is 7 quarters? Yeah, you do. What's 7 quarters? $1.75. See, we can multiply without having to multiply. We just know that. So, could you multiply these together and divide by 9? Yes, you could. Or you could see that 9 divides 63 7 times, and now that's a lot smaller. See, I always try to do this first. Samantha. Number 2? You didn't like 2, huh? The volumes of 2 similar containers are. Number 2. One volume is 115, and the other volume is 67. Okay, this is volume. So the question is, does this reduce? I don't know. No? What are the factors of 67 is prime, isn't it? That means nothing divides it. All right, so how do we go from volume to scale factor? So the scale factor is going to be the cube root of 115 over what? The cube root of what? 67. Why don't you all give me that? Cube root of 115? Oh, let's do about 4 decimal places. Okay, what's cube root of 67? 4.
0.061.
Okay. The more decimal places you have, the more accurate it will be. What's the cube root of 115? Okay. So now, they told us in 2, I don't know why they would give you such a...
How are they so close together if they're so far away?
Because that's almost 5. And that is right at 4. 4 cubed is 64. 5 cubed is 125. Does that help? So they have given us surface area of the smaller. Surface area small is 108. So what do you think we're going to do to our scale factor to prepare for this surface area? Okay, so I need to know what 4.869 or 629 squared is. Yeah, 4 more. Yeah, or 2 more. 7, 8. Okay, what is 40615 squared? Okay, now that is my area ratio. Now this is small area. Do I put that 108 on top or on the bottom? Bottom, because 16, this is smaller. So now you're going to have to say 16.4958 x is equal to, and this is definitely a multiply then divide problem. So then you'll divide and you'll get something. So this is not one that's doable in your head. What is our final answer? And this would be inches cubed, squared. Is that what they told you in the back of the book?
It said about 155.
Okay. Next. Brittany has her hand up. 31. Volume of two spheres. Now, 31, 32, you've got two of these on your test, just like this. Where all I'm asking you is to go from ratio to ratio. We've got 729, this is 31, as one volume, and we've got 27 as the other volume. This is ratio of volumes. What do we always do? We always go to what? Scale factor. Now, if you're at volumes, what do you have to do? Okay, how do you know to cube root? Because it's volume, and what did you do to scale factor to get there? Cube it. So what is the cube root of 729 in the, I can do cube root of 27. The other one's 9? Oh, well, what is that? Simplify. 3 over 1. Now, if I had gotten a decimal, I would have tried to simplify. All right, so they want to know a ratio of radii. Did you hear area? Did you hear volume? So what is that ratio? 3 over 1. Part B, find the ratio of their surface areas. What word did you hear? What do you do to this? Yes. It could be surface area, it could be lateral area, it could be base area. It doesn't really matter, the adjective. The key word is that it's area. All right, next hand. No C. I think I had a C on the test. Yes, sir. What did 20 say? No, I should have assigned 34 through 37. Did I assign those? It's a shame. All right, what am I doing, 20? Okay. What should we always do first? This is volume. One volume is 2, one volume is 250. So what do we need to do? Simplify. What divides, 2 goes into 2 and into 250? All right, now this is ratio of volumes. Go to scale factor. What's your scale factor? It doesn't matter. Right now we go to scale factor. Cube root of 1, cube root of 125. Okay, now that we're in scale factor, we're ready to do whatever they're asking. They told us that surface area of which one? Surface area of the small. Surface area of the small is 13 yards squared. They want the surface area of the large. Can we use that scale factor as is? No. We need what? We need the area ratio. So what's the area ratio? 1 times 1? 5 times 5. Now, where does 13 go? Top or bottom? Why? It's a small and one smaller than 25. So we've got x is equal to 25 times 13. You figured that out. Leslie, I think you had your hand up. 24. Two similar prisms have heights of 4 heights. Ratio of heights. 4 over 10. What should you do to that first, Leslie? And what does that become? All right, now, is this scale factor? Or is this not? Is that a yes or a no? Okay, what is it? Do you see the word area? Do you see the word volume? Therefore, it must be exactly. Okay, did you hear that? How do you determine if something is scale factor? If you see area or you see volume, it is not scale factor. If you see anything other than area and volume, it is. Okay, so the question is, A, what is their scale factor? What is it? 2/5. B, they want to know what is the ratio of their surface, and surface is not important, that's in the next word, areas. What do you do? Square it. What's 2 times 2? What's 5 times 5? Okay, C. What is the ratio of their volumes? What do you do? Cube which one? We always cube, we always square. It's all about scale factor. Okay, it's always scale factor. So what's 2 times? So we're going to do 2 cubed over 5 cubed, which is, how about 8 over 2 times 2 times 2. Okay, we reduced it. We want all of these in simplest form. 5 cubed is 125. Okay? You will never square or cube a area. You'll never square or cube a volume. You will only square and cube the what? Scale factor. And it's all about going to scale factor. And this was the first instance that we were actually there. Everything else we were never there. Sydney, what was your question? 30. Two similar pyramids, bless you. Okay, two similar pyramids, this is 30, have lateral area, that's the area of just their sides. One lateral area is 20 and the other is 45. What should we do to 20 and 45? What divides 20? 5 goes into 20 and 5 goes into 45. All right, so this is the ratio of the what? Areas. Where do we always go? Scale factor. What do we do to get from area ratio to scale factor? We square scale factor, so we have to undo that. We square root that. What will we get? Square root of 4/9 is 2/3. That is scale factor. What did they ask? The volume. All right, we've got to go to volume. So I need the volume ratio first. So what do I do to 2/3? What is 2 times 2 times 2? 3 times 3 times 3. All right, so we've got 8/27 equals. What did they give us? They said the volume of the smaller. This is volume of small. Where should 8 go? On top. Wow. So what must x be? Do you know what x is without solving it? Yeah, why? Well, the 8's are the same, so those have to be the same. But anyway, let's do it. 8x is equal to 8 times 27. We're going to divide by 8. And what happens to our 8's? They're gone. They're going to have to tell you something. It may be heights, it may be perimeter. Okay, this was not in simplest form up here, but it was ratio of area. It wasn't scale factor. And it's because they told us lateral areas were. Yes, sir.
Did you have those on the EOC?
What was the EOC?
No. It was part of
What did we talk about? What theorem did you have to do? Angle. And what does perpendicular lines give you? 90-degree angle. So do you have two equal angles there?
Huh?
Do you have two equal angles there?
I have one. At 90 angle?
Did you look at the given? Did you even look at it?
Triangles, yeah. Yeah.
And I gave you everything you needed yesterday. I told you. Yeah, I did. What does that say? Smartboard notes? Where's 11.7? She's just saying, I told you everything. I don't care. I went through the whole thing. If ST is perpendicular to TC, what do you know? What do you know? What does perpendicular mean? 90. Where's the 90? How do you name that angle? STR is a what? Right angle. Tell me that. Okay. Are you given another perpendicular? ER and RC? What do you know about this? It's a right angle. So what are you going to tell me about angle ERC? It's a right angle. So there's your first step. Now, what do you know about right angles? So you know that measure of angle STR equals the measure of angle ERC, which equals what? 90. So now do you have one pair of angles equal? What angle do they share, Trevor? There's one angle that they see. So what do you know? Angle C is in the big, angle C is in the little. What do you know? Why is angle C congruent to angle C? What's that called? Reflexive. Now, and I listed all those things yesterday here. We talked, yeah, I did, and we talked about which one you were going to use. Any other questions? 22. You're packaging a cylinder with a 4-inch diameter. All right, so we got to be careful. We have a cylinder, 4-inch diameter. Now, if the other one's a diameter, we might be okay. We'll see. And a 6-pound height, or 6 high, that's a diameter, holds 1 pound of oatmeal. In other words, that would be its volume. To the nearest ounce, 1 pound, PB, LB. They told us that 1 pound is 16 ounces. So can I make this 16 ounces of oatmeal? That's a volume measure, ounces. Oatmeal. Okay, that's my volume. Let's see, how much oatmeal will a similar 10-inch high cylinder, 10 height, hold? So, what information is not necessary? I don't think the diameter is important. Ounces is a liquid measure, correct? A volume measure. Because if you look at a measuring cup, it tells you ounces. So what is the scale factor? Why? But that's in inches. And we need ounces. Well, but wait a minute. They told us the volume of this little one is 16 ounces. We got to find that. But is that not a volume measurement? When you drink a soda, doesn't it tell you how many ounces you're drinking? Okay, so this 16 ounces is volume. Watch. What's the scale factor? 6 over 10. Why do I use 6 and 10 and not 4? Because they're both what? Heights. What does this reduce to? 3 over 5. If I need volume ratio, how do I get my volume ratio? I cube it. So let's cube it. What do you get? 27 over 125. Where does the 16 go since it's volume, top or bottom? Why? It's associated with the 6, which is smaller than 10. We want the volume of the larger one. So we're going to say 27x is equal to 16 times 125. Divide by 27, what do you get? Multiply, divide. 2.
74.07.
0.7? Notice we're not doing ounces cubed because ounces is a volume measurement. Just like when if you were in metric and you're using liters or milliliters, you don't do that cubed because that's already a volume measurement. Yes? What did 14 say? Ah, surface area.
It's like 25, 125.
So is this scale factor? No. How does this reduce, by the way? I think we divide by 5. So we're going to get 4 over 25. Now, how do you go to scale factor? It's area. Square root of 4, square root of 25. All right, in 14, they're looking for volume. The volume of the large, and this is the volume of the large, is 192. So what am I going to need to do to my scale factor? Pardon? Cube it because I need my volume ratio. So 2 cubed is 8, 5 cubed is 125. Where do I put the 192? Bottom because it is the large. So we got 125x is equal to 8 times 192. So, bless you, whatever 8 times 192 divided by 125 is. I don't know what that is. But you all have the calculators. Sure.
12.29.
And that's yards cubed. That's a lot. Anything else? Yes, sir? What 32 say? Oh my gosh. Trevor? Volume of one is 1331. Volume of another is 2744. How do you write that as a ratio? Is that scale factor? How do you do it? Does that simplify? Okay, how do you get scale factor? Cube roots. See if that's cube rootable. If that's not cube rootable, I go back and think about simplifying again. 11. All right, this is 32a. What is the ratio of their heights? Why didn't you square it? Why didn't you cube it? It didn't say what word? Volume. Now they want ratio of the surface area. What do you do? So it's going to be 121 over Yes. Yeah, you could do that too. A clown's face on the balloon is 4 inches tall when the balloon holds 108 inches. So the clown is 4 inches when the volume is 108 inches cubed. How much air must the balloon hold for the face to be 8 inches tall? So what's your first ratio? Okay, what does that reduce to? 1/2. All right, is the scale factor ratio of areas or ratio of volumes? Is the scale factor ratio of area or ratio of volume? Okay, are those inches squared? Are those inches cubed? This is the height of the clown's face. So what is this? It is scale factor. This is volume. What are we going to have to do? Which ratio do we need? The volume ratio. What do we do? Cube it. What's 1 cubed? What's 2 cubed? All right, where does the 108 go? Top, because it's associated with the 4, and now you finish it. I need your homework turned in. You have a review assignment tonight. You got a test on Friday. Yes? I got everything done. Would be a more appropriate term